Hello, my name is Jakob Rasmussen, and I am thrilled to invite you to the first episode of Green Therma's podcast, Heat Forever. Green Therma is a pioneering startup based in Copenhagen, Denmark, attempting to revolutionize the way we heat our homes by harnessing the Earth's natural energy. Green Therma provides a revolutionary system that is completely carbon neutral. The company has plans to expand into Aalborg, Hamburg, and Houston, Texas, and is poised to become a global leader in clean and reliable heating solutions. Through this podcast, we will be sharing our love for geology and for exploring groundbreaking geothermal technologies. For today's inaugural episode, we are honored to have a very special guest, Kim Maver. Kim wears many hats at Green Therma as the company's chief geologist and chief marketing officer. Kim brings a wealth of knowledge about the subject to the table. Kim, thank you so much for being here.
Thanks for having me.
It's a pleasure. How are you feeling today?
I'm feeling fine. This is my first podcast. I've done many webinars, but first podcast, so it'll be exciting.
Yeah. There's not a huge difference between them, so I think that you'll tackle this wonderfully.
I'm sure I will.
So first of all, I'd like to ask you about your background. So tell me, how did you get involved into the world of geothermal energy, and how did you become the chief geologist at Green Therma?
So again, passion for geology. So after high school, I decided to become a geologist. So I studied at the University of Copenhagen. After finishing my master, I went on to do a PhD at the GEUS, or Danish Geological Survey. So again, you can see the passion there. I've also a commercial degree. And then I started in the oil and gas industry in a Danish company. I ended up being managing director for. But that was really to map the subsurface, so really relevant for geothermal as well. And then I decided to move abroad for quite a few years. So I lived in Oslo, I lived in Paris, I lived in Aachen. And then 2 years ago, I came back to Denmark and I was one of the co-founders of Green Therma. And since then, it's just been a fantastic journey. There's so much interest for geothermal energy.
Yeah. Okay, fantastic. Very exciting background. But what's so special about geothermal energy? What drives you to this area?
So I've never had that much focus on geothermal when I was doing oil and gas, but the more I look at it, the more amazing I think it is. So one of the things I like to tell people is that 99.8% of the Earth volume is more than 100 degrees hot.
Okay. Wow. All right.
And 99% is more than 1,000 degrees hot.
Really?
Yes.
Okay.
So we have a lot of energy down there. And look at Iceland. I think they believe they have slightly too much geothermal energy because they have all the lava coming up all the time.
Right.
So I think it's important to understand that every kilometer you go down, on average, on land, you increase the temperature with about 35 degrees. So we have an abundant amount of energy. We just need to get it up.
Okay. And what are the applications then of geothermal energy? How can we use this energy you described for the benefit of humanity?
So I think that original application was actually Roman spas, for example. And they've been going on for many thousand years where people are actually bathing in this hot water. Because
really?
It was there, yeah.
Okay.
Even animals. There's an ape park in Japan where the apes go down and bathe in wintertime because they have the hot water. But back to more modern days, say for Denmark, district heating.
Okay, yeah.
You get hot water up. It can be circulated directly out to the end user in district heating network. So that's one major application, which is very relevant for Denmark, of course. But in the world, there's even bigger demand for cooling. So you can actually take the heat you're getting up, you can convert that to cold water with a little energy loss and circulate it out through radiators and cool the houses. So instead of have air conditioning units, you have a normal radiator that gives you the cold water.
Okay. So you can heat up water to cool it down and also cool your house.
Yes, it's a little bit complicated process, which we'll take another day. But this, that is possible.
Okay.
There's another thing you can do. Breweries, dairies for pasteurization, making cement.
Okay.
So those temperature ranges we're talking about, 100 to 150 degrees, you have a direct application as well.
Okay.
You could even use these geothermal wells to recirculate very hot water from the surface that's hotter than the subsurface. You reheat the subsurface, for example, in the summertime, and then you extract this extra heat in the wintertime. So it's a heat storage facility as well.
Okay, so you can store the heat and use it whenever it's needed.
Yeah. And then the last big application would be electricity. But again, temperature certainly in Denmark is not the best for electricity. But that's where you see other places in the world like Iceland, California, Philippines, Indonesia. There they use it for electricity as well because the water is so hot and so close to the surface.
Oh, okay. Wow. So how would you compare that to other like renewable energy sources, stuff like wind and solar and hydro?
Yeah, so I think that's the three main ones.
Mm-hmm.
The first problem with those is they are intermittent. So if it's not raining, you have a problem with hydro power. If the sun is not shining, which is only about 20% of the time, you have no...
And 5% of the time in Denmark, right? Oh, in winter at least, yeah.
Exactly.
Yeah.
And the wind, I think we say, is blowing about 40% of the time. So you don't have a constant source of energy.
Right.
Geothermal is 100% constant.
Okay,
Earth has been here for 4.5 billion years. We believe it'll be for another 8 billion years. So the amount of energy we're getting up is completely constant. So it's 24/7 for our lifetimes and many lifetimes beyond that, where we'll get this amount of energy up.
Right.
So there's never stop in energy production. So that's one thing. The other thing is the surface footprint.
Okay.
You've seen the windmills.
Yeah, that's hard to miss them when you're in Denmark, right?
And I think that's the whole problem. And they can actually be very noisy. Solar panels covering big fields don't look very nice. And they actually make a buzz on noise as well. If you look at a geothermal application, the only thing you need for the application we have is just a small garage for a regular size car, a 20-foot container on the surface. And that's it. Everything else is below ground.
Okay, yeah. Like the heat, especially, and
exactly.
that's not going anywhere. That magma and all that, the hot temperatures is there to stay forever, right?
Yes.
Well, it sounds incredible. It sounds too good to be true. It sounds amazing, right? We talk about all these applications and how it doesn't go anywhere. It's literally underground for us just to go and get it. But how come you don't see that many garage-sized installations all over the world? Like, why is not every country using this stuff?
And part of that problem has been it's expensive to drill, but also just getting the heat up. So conventional solutions have a problem getting enough heat up in an economical way. And that's where a green thermal solution can do that in a more efficient way.
Okay. Please elaborate. How is green thermal so revolutionary?
It's a little bit complicated. So it's actually 3 pipes. So we drill down 3 to 5 kilometers vertically. So we reach maybe 100 to 150 degrees. And then we drill horizontally at the same time, 2-3 kilometers.
Okay.
So you have a complete enclosed well that's 7 kilometers long.
So an L-shaped pipe that goes down.
Yeah,
okay.
Yeah.
Is it hard to drill horizontally? Is that challenging?
Well, if you don't know what you're doing, absolutely.
Right.
But if you look at the U.S. Shale wells in the U.S., 70% of all those wells are actually this type of design where you drill down and then have a horizontal part.
Okay.
So many hundreds of wells are drilled every day with this type of technology.
And how long is the total pipe? It's what, 5 kilometers down and
2 horizontal, 2 to 3, so 7 kilometers.
Okay. And is it like a perfect 90-degree? I'm just trying to illustrate what this looks like for our viewers.
Yeah.
So
it's a soft bend, so it bends over like 500 meters.
Okay. Soft bend. So it's kind of like, how long are the pipes by themselves? Are they
about 10 meters?
10 meters. Okay, so it's kind of like so it's kind of like making a curve with a bunch of matchsticks, right? So if you stack them onto top of each other, you'll eventually get
spot on. Yes. Exactly.
All right, fascinating.
Yeah. And then our trick when we want to get the heat up of the ground is that we are not putting water into the ground, circulating it through the geology. This is a closed system.
Right.
So this outer pipe here, 7 kilometers, inside that we stick another pipe that goes the whole way for the well, but it's actually open at the end.
Okay.
And then we take cold water, for example, from district heating plant, 45 degrees, that goes down between the inner and the outer pipe, goes along the horizontal section, where it's then heated to the temperature of the subsurface, which would typically be 100 to 150 degrees, and then returns in the inner pipe and goes all the way to the surface. Initially, it'll be over 100 degrees. Then over 5-10 years, it probably drops to about 90 degrees, and we can maintain that temperature for the next 50 to 100 years.
Okay, wow. So it's 2 pipes in one.
Yeah, it's actually 3 pipes in one.
Oh, 3 pipes, right.
Yeah, but I only said 2 pipes. So the inner pipe that takes up the hot water is actually 2 pipes.
Okay.
There's one long pipe inside the other, and between these 2 pipes, there's a vacuum.
Oh, okay, that's dual vacuum,
That's a dual vacuum, yes. So you're insulating the upgoing hot water from the downgoing cold water. So instead of losing 30-40% of the energy, you only lose 2-3% of the energy. And that's really our invention.
Is that the pipe, the dual vacuum pipe, can actually retain the heat that it gets stuck and it doesn't lose it. when you think about like a pipe that has cold water and hot water going through, like how when the laws of thermodynamics kind of cool down the water, right?
Yes.
But I guess it's kind of like what, like a thermal flask, right?
Exactly.
Okay.
So this is a 7-kilometer long thermal flask.
Wow. All right.
As simple as that.
A lot of coffee in there, potentially. If you
That's
want
one
to.
option.
Yeah.
But I think we're going for hot water.
Hot water. Perfect. Yeah. That's a
But-
lot more useful, I think, especially in this situation.
Yeah.
Wow. All right. Well, considering all you just told me about DualVac and Heat Forever, what do you think will have to change for geothermal to be widely spread and used globally?
So I think one of the challenges have been the drilling costs. So drilling these wells compared to how much energy you get up, it has been a problem. So we need to bring down drilling costs, and then we need to make the heat extraction more efficient. But that's where Green Therma believes we have something that can really contribute to making it cheaper to get up the hot water.
Okay.
So I think that needs to change. But then you also need somebody to actually take off the hot water. So you need a whole industry, district heating industry, district cooling industry. But that is changing as well. So all the regulation is changing. EU has put geothermal very high on their list of priorities.
Oh, really? Okay.
Yeah. So we can see there's more interest for geothermal. People know they have to replace gas. Biomass for district heating, for example, is biomass green or not green or renewable?
That's a huge debate.
That's a huge debate where this is really green. So if we look at the conversion factors, you have a COP, so that's how much electricity you need to generate one unit of renewable energy. Most of those are 1 to 5. We think in much of our applications we're up at 1 to 50. So it's 10 times more efficient converting electricity into something that's renewable.
Okay, and for a country like Denmark that has a wide district heating network, would that be just a climate game changer for Denmark?
I think so. So 65% of Denmark is covered by district heating, and then there's a lot of places where they again need to replace biomass, electricity from heat pumps, even some places with coal, and geothermal would be obvious candidate for that.
Yeah, it sounds incredible. The idea of the heat from the earth coming and heating your home in winter.
Yes, and in theory you could actually plug your radiator directly into the underground, but you normally would have some heat exchangers and things in this container on the surface. But you could take it directly into your own pipes.
Yeah. Okay. And are you a big believer that this can be used all over the world, every continent, every country?
Back to what I said earlier, each kilometer you go down is 30 degrees hotter. So if you go down 3 to 5 kilometers, you get to 100, 150 degrees. And that is the case everywhere on Earth. The challenge is that the geology or the hardness of the subsurface are different. So sometimes it's a little bit too expensive right now to drill compared to how much energy you get up. But if you could solve that puzzle, we have plenty of energy.
Okay, so that just requires good geological surveys of the areas.
Exactly.
Yeah.
And then some development in drilling technology, for example.
Okay. Thinking about the future then of this technology, where do you see this? Where do you see the role, or what do you see the role of geothermal energy being for use for heating in 20 years' time? Do you think it'd be more common than it is now? Do you think it'd be a widely used application that will overtake the other sustainable energy sources we talked about, like solar and wind, and not to say, of course, as well, like other conventional systems like gas and oil?
I think geothermal will be a key pillar in our energy supply in the future. A lot of discussion on what's going on in the US, but even in the US, they're still very keen on geothermal. They also see the benefits of it. So I think...
Because drill, baby, drill also applies to this.
Exactly. Same technology. So a good point. 80% of the technology and knowledge you need to drill geothermal well can be taken directly from oil and gas industry. So you can take all the people that's in oil and gas, maybe want to leave that business, can come to geothermal from day one and actually support this industry.
Okay. Well, that's really incredible stuff, Kim. Honestly, thank you so much for explaining this whole thing. Do you have any final remarks about geothermal energy? Maybe I've forgot to ask a specific question about something you want to get off your chest,
Yeah. No, I just think we're going into a geothermal era. I think in the next 10 years, this will really grow because it's on all parameters, is such an obvious benefit for society.
Yeah. No, really, really. And it's just absolutely incredible stuff. I really hope I wish Godspeed to Green Therma on their
Thanks.
future projects, and hope really that in 20 years' time, when I'm in my 50s, I can be able to heat my home with a geothermal solution. That would be incredible.
I'm nearly sure I can promise you that.
Awesome. Well, thank you very much, Kim.
Thanks.